Good morning everyone. Today I am going to present our final project, which is vision-based smart attendance monitoring system using facial recognition, which will be presented by me and my partner Samima, which was done under the supervision of Dr. Anjan Kumar Talukdar sir and Professor Kandarpa Kumar Sharma sir, and under the co-guidance of Dr. Surajit Deka sir. So this is the outline of our presentation, which includes introduction, motivation, literature review, block diagram, methodology, the architecture of the system, the works we did in phase 1 and phase 2. The rest part includes objective, challenges, future work, conclusion, Gantt chart, etc. So, for introduction, as we all know, a person has distinctive facial features and structures. So why not use it to identify or verify an individual? So a facial recognition system uses those features to identify and verify a person. Motivation. So we all know as traditionally attendance is marked by teachers, but sometimes this is erroneous as we all know due to fraud and proxy cases. So why not use a new method to mark the attendance which is accurate and efficient. Face detection. We all know face detection is a computer technology which is used to identify like faces in images or videos. Face recognition. Recognition is a computer technology which is used to verify the identity of an individual by using the features of their face. It can be used to identify people in photos, videos, or in time. So, we also need a database. So how we create a database? Database is the collection of face images and extracted features. The database also includes the name of the students and roll number for each student. We create a database by taking like 10 to 50 pictures per person, images per person by using the camera. Literature review. These are the literature review which provide us with some idea. This is the table of the literature review. Applications. What are the applications of our project? It can be used to prevent proxy. It can be used to like identify unknown person if he or she is sitting on our class, any suspicious person is sitting on the class. It can be also time saving. Problem identification. So for the first stage, we decided to develop a system where attendance will be taken periodically after regular intervals. It means the camera will pop up after regular intervals which will be specified by us, and the number of times it will pop up is also specified by us. Therefore, by using this technique we can increase the efficiency of the system. Problem statement 2. In phase 2 we decided to introduce an intruder detection system so that if any unknown person or like any stranger or any suspicious person is sitting on the class, we can identify it, therefore increasing the security. So this is the block diagram. The block diagram consists of the camera. So we use the camera to take a picture. After taking the picture, the region of interest, that is the facial part, is detected, and from that part facial features are extracted. Those features are extracted and then matched with the database. If it is matched, then facial recognition, then the attendance is. So tools and technologies required. We need machine learning algorithms such as LBPH algorithm, Haar cascade classifiers, image processing. For image processing, we used Python and OpenCV library. Image processing basically includes like grayscaling of the image. For graphical user interface, we used Nikita library. We need a camera module, computation system, and a database system. So these are the libraries that we used. So this is the architecture of our system. In the first part, for registration, we have to first register and we have to enter some details which includes the enrollment number and the name. After that, the system will capture our image and the face detection part will be done, and the pre-processing means the image will be grayscaled and after that features will be extracted from the region of interest, and using LBPH algorithm model would be made. For the attendance part, first we'll have to put the details of the subject, and after that the system will start capturing the image, and after that using hierarchy cascade it will like perform face detection and then classify it. Then from the model we will classify and match with it. If it is matched, then it will go on the CSV entry and get stored, and if it is not matched, an intruder alert system will start. So this is about the algorithms we used. We used local binary pattern histogram. So in this system as a threshold value, and if the value of the neighboring neighbors are more than the central pixel, we mark it as 1, and if the values of the neighbors are lesser than the central pixel, we mark it as 0. And in this way we will get a like a binary value, and we can convert it to decimal value, which will give us a like new information about the image. So these are the working principle of the algorithm. uh, So first, a image or dataset, video dataset is taken, and our feature-based cascade classifier is used, in which we have put up the parameters as grayscale image, and the scale factor is 1.2, which basically means that reducing the size of the image, and the minimum number of neighbors like it should satisfy in order to be classified as a face is 6. So for the LBPH algorithm, first the video dataset is taken, and 70 more up to 70 pictures are taken, which are extracted into frames. So from the frame dataset, then pre-processing is done, which is means conversion to grayscales, and then the features are extracted. So after the features are extracted, we label the images with enrollment number and name. For the feature extraction part, we set the parameters as radius as 1, neighbors as 8, and threshold is 100. These are the parameters that we use for extracting the features. So after that we calculate the Euclidean distance between them. The lesser the distance, if it like satisfied a threshold, it will be marked in the attendance database. Project flow and explanation. So for the starting part, we have to start it first register, then the images will be stored in the system. Then again the camera will pop up and capture the user image, then recognition process will start, and it will start comparing with the database. If it's matched, the student will mark as attended present, and if it does not match, it will be like absent. After marking present to the students, a file generated with attendance details of the student will be made, and attendance will be automatically updated. And so for the next part, we have intruder detection. Intruder detection system is a like monitoring system which can like detect unwanted strangers who should not be present in the certain area. This is the confusion matrix of the attendance system and the face recognition that we did, and we got the accuracy as 73.43%. So now the importance of intruder detection. It helps to like identify and alert authorities about intruders. It also ensures that only authorized individuals are allowed to make their attendance. And the flowchart of the system. First, the camera pops up, face is detected, face is recognized. If the person is known, then if it is matched, then her name or his name will be displayed on the screen, and if it is not matched, then will be triggered. The steps of implementation are pre-processing steps, which includes grayscaling and noise reduction, face detection using hierarchy cascade. These are the parameters as I've explained earlier. Face recognition using LBPH. These are the parameters, and thresholding, like it would have to satisfy certain threshold in order to be matched with the database. So after that, profile matching from the database and alerting if intruder is detected. So these are the observations. This is the confusion matrix of our intruder detection system. Here we found the precision to be 0.66, recall value to be 0.59, and accuracy to be 0.6. These are the graphs of the different parameters of our intruder detection. So now for project plan explanation part, after we run the system, this is the main screen of the system. We have to select the register new button. After that we'll have to put up the details such as enrollment number and name and press the take image. The camera will pop up and it will start taking the pictures of the face. After taking the picture of the face, we have to press the train image button and the image will be trained successfully. After that we'll have to close this window. This is the dataset of the images taken after converting it to grayscale. For taking the attendance part, we have to go and click the take attendance part and this window will pop up, and then we'll have to enter the subject and press the fill attendance button. As we can see, the system has correctly identified the individual along with her enrollment number, and so our system can detect multiple faces at a time also. So we can also view the attendance. Here is the file where we can see the attendance, and it is shown in a tabular format. After that, if a certain person is not registered, or if she or he is not meant for the class, the intruders detection system would be alerted. And as we can see, since my model is not trained here, I am detected here as an intruder. So what are the objectives? The objectives were to make the attendance marking and management efficient, time saving, simple and easy. Preventing proxy was one of the major things we wanted to do. And also in this COVID time, contactless attendance taking is very important. So these are the challenges we get in our attendance system, such as it pose variation, variation in expression, aging, similar faces, lightning conditions. One of the challenges our system has is in identifying twins, in differentiating between twins. So for the future work, we want to make it more accurate and more efficient, just as I said earlier, so that it can identify the twins also. And if someone has undergone a drastic accident, so it can and it has resulted in the change of a spatial feature, so we hope that it can identify those persons also. And also, we for the future work, we want to track specific students in real time also. The major scope for the future work is to improve the algorithms detection range. So this is the video demonstration
Now
of our
I'll show
project.
you the video demonstration of our final year project, which is vision-based smart attendance monitoring system using facial recognition. So now I'll show you the working of our project. So for the first step, we'll have to select the register a new student button and put up the necessary details. For example, I am putting the details of my project partner, Samima. And next we'll have to press the take image button, and after that the camera will pop up and take about hundreds of images. Next we'll have to press the train image button in order to successfully train the models. As we can see in the notification that the image was trained successfully, we close the window. Next we press the take attendance button and we enter the subject. For example, I am putting as ECE111 and press the full attendance button. As we can see, it has correctly identified Samima along with her name and roll number. And now the camera will pop up for like a number of times. In our case, we have specified it up to 4 after interval, after like certain interval, and in our case, we have specified it for 5 seconds. So now we can see that our attendance was